In this video, we will solve problems involving the arc length of a circle. The arc length is some portion of the circumference. So if you look at this, this bold length of 16, this is an arc length on this circle. And the key is what I just said. Arc length is a fraction of the circumference. The circumference is the length of the entire circle. We can take this sentence and turn it into a formula. I'm going to use the letter L to represent arc length. So arc length is a fraction of the circumference. What is this fraction that I'm talking about? Well, if the central angle is theta, then theta is some portion of degrees from the entire circle. So if I say theta over 360, because we know the entire circle has 360 degrees, that's the fraction that we're talking about. By the way, the measure of this central angle and the measure of this arc in degrees, those are the same thing. What about the circumference? What is the formula for circumference? The formula for circumference is 2 pi r, where r is the radius of the circle. In this case, it's 7. So I have now turned this sentence into a formula. Arc length is a fraction of the circumference. Arc length equals this fraction times the circumference. Okay, I'm just going to erase this to make space for myself. Let's go ahead and fill in what we know. The radius of the circle is 7. Okay, so I know I'm going to have, so I will have theta over 360 times 2 pi 7. The length of arc AB is 16. So we're given the arc length. So that 16 is going to go right here. Find the measure of arc AB in degrees. Well, that's just the theta. I told you that the central angle and the measure of this arc in degrees, that's the same thing. So luckily, we have filled in all of the other variables except for theta. So it's just a matter of solving this equation for theta. Notice that we have 2 times 7, so that's going to make 14. So might as well do that. So I have 16 is equal to theta over 360. And then I've got this 14 pi. In fact, I think I'll put that in the front. So I've got 14 pi times theta. That makes it more obvious that what I need to do is reduce the fraction 14 over 360. So I'm going to do 14 over 360. And that's 7 over 180. So I'm just going to move that over here. So I have 16 is equal to 7 pi theta over 180. So all I did is I reduced 14 over 360, and that became the 7 over 180. The pi and the theta are just sitting there. So now it's time for me to solve this equation for theta. In order to do that, I'm going to multiply both sides by 180. All right, so I'm going to multiply by 180 on the left and the right. So let's see, 16 times 180. That's 1,280. So I've got 1,280, whoops, forgot the 0. is equal to 7 pi theta. So the 180s just cancel each other out. I'm trying to get theta by itself, and I'm at the end of the problem because all I need to do now is divide both sides by 7 pi. Okay, that will get theta by itself. All right, so I think we want decimal. So let's just go ahead and put this in our calculator. 1,280 over 7 pi. So that's 52.21. I'll give 2 decimal places. So 58.21 degrees. All right, so that's the answer to problem number 1. Let's take a look at problem number 2. Let's start by writing down the formula. We're still dealing with arc length. So remember, arc length is some fraction of the circumference. Okay, arc length equals this fraction of the circumference, and we know the circumference is 2 pi r. Let's fill in what we know. The measure of arc AB is 88 degrees. All right, that tells us that the central angle here is 88 degrees. That's theta. The length of arc AB is 7.37 feet. So we are given the L, which is 7.37. We're given the theta, which is 88 over 360. Well, the theta is 88, so I've got 88 over 360. And we've got the 2 pi r. So this time we are being asked to find the radius. But other than that, this is going to be pretty similar to what we had before. So if I do 2 times 88, that's going to be 176. So this problem is 7.37 is equal to 176 pi r over 360. All right, I just multiplied the 2 times the 88 so far. And this 2 pi r, it's like it's over 1. And I'm just multiplying numerator times numerator and denominator times denominator. It is time to try to get r by itself. So I want to multiply both sides by the denominator. Actually, I think I want to reduce this fraction first. I like the numbers to be smaller. So I'm going to reduce 176 over 360. All right, so that's 22 over 45. So I'm going to have 7.37 is equal to 22 pi r over 45, right? 22 over 45. So now I'm going to multiply both sides of the equation by 45. So that will cancel out these denominators. So if I do 7.37 times 45, I said times 45, that's going to be 331.65. So I've got 331.65 is equal to 22 pi r. All I have to do now is divide both sides by 22 pi, and that will leave r by itself. So divide by 22 pi. So that's really it. So 331.65 divided by 22 pi is 4 point, well, I got to round this up, so 4.80. And let's keep the units. The length is in feet. So this is the radius in feet. All right, let's take a look at problem number 5. This one's extra fun because it involves a pizza, but it's really just a regular old problem. A pizza is cut into 8 congruent slices, each with a central angle of 45 degrees. If each slice has a 7.07-inch crust, what is the pizza's radius? Well, the key is right here, each slice. So really, all you need to do is focus on one slice of pizza and you will be golden. So they tell us that the arc length, which is the crust on one slice of pizza, is 7.07. So we have 7.07. But they also give us the central angle. So the angle, which I've been calling theta, maybe I'll just put it over here, theta is 45 degrees. So let's go ahead and set up our formula. Remember that arc length is some fraction of the circumference. All right, arc length is a fraction of the circumference. So all we need to do is fill in what we know. Well, we know that the arc length is 7.07. So we have 7.07. We know that theta is 45. So we have 45 out of 360 times the circumference, which is 2 pi r. The radius is the only variable, so we should be able to find that no problem. You don't have to reduce if you don't want to, but I'm always going to reduce because smaller numbers are easier to work with. 45 over 360 reduces to 1/8. So you would get the same answer if you did not reduce right now. Okay, but I find 1/8 is more pleasant to work with. Okay, and I've got my 2 pi r. Look, guys, if I were to put a 1 under this, if I multiply numerator times numerator, I'm just doing 1 times 2 pi r. So that's just 2 pi r. So I think you won't mind if I just put the 2 pi r in the numerator. So I think you can understand that this is the same thing as simply having 2 pi r over 8. This further reduces because 2 goes into 8 twice. So I think I'm just going to reduce this one more little step. So I have 7.07 is equal to pi r over 4. Okay, I just further reduced the 2 and the 8 just now. Became 1 over 4. So now I'm going to multiply both sides by 4. So I'm going to multiply by 4, multiply by 4. So 7.07 times 4 is 28.28. That makes sense. So I've got 28.28 is equal to pi r. All right, the 4's cancel each other out. I'm trying to get r by itself. So I just need to divide both sides by pi. And then I'll be done. So these pi's cancel out. So that means this is going to be the final answer. So we've got 28.28 divided by pi. Okay, so if I round it 2 decimal places, this will be 9.00. So the radius is 9.00. Let's not forget the units. The units are in inches, and they must be included for full credit. All right, let's do one more problem. Skipping to problem number 8, we're going to find the perimeter of the track's inner edge, shown here in bold. So we just need to find basically the length of this bold oval. Well, we already know most of this length is really given to us, because the length of this straight line, which I'm highlighting in purple, we are told that is 1,300 feet. And of course, that's going to be the same as the straight line on the other side of the track. So this is also 1,300 feet. So the only portion of the track that we don't know is the curved portion on the ends. All right, we don't know this portion that I just colored in red, and we don't know this portion over here. Well, these two red portions are both semicircles. If you took the portion from the left and the portion from the right and you stuck them next to each other, you would have a circle. So just keep that in mind. We really need to know the radius of this circle for us to do the problem. And look, they told us that the entire length right here from one side of the circle to the other, this is 820. So that means the radius will be half of this. So obviously that's going to be 410. Hopefully you don't need a calculator for that. So if 820 divided by 2, of course, is 410. So that means that the radius is 410. Okay, so keep that in mind. The radius of the circle. So the circle is the missing length. So basically, we need to find the circumference of this circle that we would get if we stuck the two ends together. We need the circumference of this circle. Okay, so I'm just going to use the letter C for circumference. And we know that circumference is 2 pi times the radius. So we know that the radius is 410. So the circumference will be 2 pi times 410. Oh, that's weird. We're multiplying by 2. So that means we're going to get the 820 right back again. So we have 820 pi. That is the circumference. So the perimeter, which I will just write P for perimeter, is going to be the sum of the straight parts and the circumference. So if I take the two straight parts of 1,300, if I add those together, and if I add in the circumference, which is 820 pi. All right, that gives me the entire length of the track, the straight parts and the curved parts put together. So that should be the perimeter. So let's just calculate all that out. So I'm doing 1,300 plus another 1,300 plus 820 pi. So that is 5,176.11. And the lengths are in feet. Don't forget your units. So that is how you solve problems involving the arc length of a circle.